middle to light refraction. Refraction is the change of light path when it travels from one transparent medium to another. We mean like when it travels from air to water of another optic density. It means that if we have a swimming pool here, this is the water, this is the air, and this is the water. This is the line separating between the air and water, and this is the normal, which is the perpendicular line. If I have a light torch, when the light moves in the air, it moves with a certain speed, which is very fast. Then when it moves from the air to water, it changes its speed and also it changes its direction, and we say it refracts. All right, this is the incident ray. And this is the angle, number 1 is the angle of incidence. And this is the refracted ray. Number 2, angle of incidence is bigger than angle of refraction. And we say that the light ray refracts towards the normal. This is the first case of light refraction when it passes from one transparent medium of a lower optic density to a transparent medium of a higher optic density. Optic density is the ability of the medium to refract the light ray. Optical density is the ability of the medium to refract the light ray, and it depends on the speed of light in this medium. And we have to say once again that the light has its highest speed in air. So the speed of light in air is the highest, and it's higher than any other medium. The other case is if I have a swimming pool with a torch under or lamp under the water, so the light will pass from the water or from the higher optic density to the air out to the lower optic density. In this case, if I have a torch or a lamp under the water, and this is of course the normal, so this is the incident ray, the light ray will refract away from the normal, and this is the angle of refraction. And in this case, when the light is traveling from the higher optic density to the lower optic density, angle of incidence is smaller than angle of refraction. And the light ray refracts away from normal. These are the two cases. The other case that we have is when the light travels into a glass block. It's a block of glass, a rectangle of glass, and in this case, the light refracts 2 times or twice. How is that? When the light passes from the air to the glass of the block, it refracts like in the first case from a lower optic density to a higher optic density with the angle smaller than the angle of incidence. This is called incident ray. This is called refracted ray, and it keeps moving inside the glass until it comes out of the glass. And here is like the second case where it comes from higher optic density to lower optic density. And the light ray coming out of the block is called emergent light ray, and this angle is called angle of emergence. So the refraction happened twice, one from air to glass and the other from glass to air. All right, these are the definitions of the angle. Angle of incidence between the incident ray and the normal, angle of emergence between the emergent ray and the normal. And these are the laws or the two cases of light refraction that we talked about before. And the special case is when you hold a torch perpendicular to the line between the air and the water, or the water and the air, the light ray passes without refraction. The light ray perpendicular to the surface between the two media passes without refraction. We also have the absolute refractive index, which is a ratio between velocity of light in air and velocity of light in any other medium, and we calculate it by the rule velocity of light in air divided velocity of light in any other medium. And because velocity of light in air is very low compared to any other medium, very high compared to any other medium, so the speed of light is higher than any other medium, so the absolute refractive index is always greater than 1, because the speed of light in air is higher than the speed of light in any other medium.